Hello everyone. Today I am going to explain about the particular integrals with two types. First one is particular integral of f of d into y is equal to q of x when q of x is equal to sin bx or cos bx where p is a constant. Next, particular integral of f of d into y is equal to q of x when q of x is equal to x power k where k is a positive integer. First, I will explain with q of x is equal to sin bx or cos bx. That is, particular integral of f of d into y is equal to q of x when q of x is equal to sin bx or cos bx. First case is, let f of d into y is equal to q of x is equal to sin bx. So particular integral equal to standard form 1 by f of d into q of x is equal to sin bx. So if q of x is equal to sin bx, you can consider a function with d square, means that in the f of d, first we have to consider the term d square. So that's why we can write the function in terms of d square, that is called phi of d square. So particular integral is equal to 1 by phi of d square sin bx, and put d square is equal to minus b square. So you can multiply b square into negative sign, that is minus b square. So we get the particular integral for q of x is equal to sin bx is, particular integral is equal to 1 by phi of minus b square sin bx if phi of minus b square not equal to 0. So next case is, means in this case next term is cos bx, that is particular integral equal to 1 by f of d into cos bx. So in case of q of x is equal to cos bx, again we have to apply the same procedure. We can consider the d square terms, that is let f of d is equal to phi of d square. So write particular integral is equal to 1 by phi of d square cos bx, put d square is equal to minus b square, we can get the particular integral equal to 1 by phi of minus b square cos bx if phi of minus b square is not equal to 0. If phi of b square minus b square is not equal to 0, simply we can substitute d square is equal to minus b square. So second case is, let phi of minus b square is equal to 0. So in this case our f of d in the form of d square plus b square, if you substitute d square is equal to minus b square, directly we can get f of d is equal to 0. In this case we have direct formulas to write for the particular integral is, particular integral equal to 1 by d square plus b square sin bx. If it is a sin, then you can write minus x by 2b cos bx. So this is a formula for finding the particular integral if phi of minus b square is equal to 0. So next one is, if q of x is equal to cos bx, particular integral is equal to 1 by f of d in the form of d square plus b square into cos bx. Directly you can write the formula is x by 2b into sin bx. Simply you can remember it. X by 2b is common for both. Depending on the integration you can write the term. Cos bx integration is sin bx and sin bx integration is minus cos bx. Simply you can remember the formulas like this. So first example is, solve d square minus 4d plus 3 into y is equal to cos 2x. So any second order differential equation, means that higher order differential equations in the form of f of d into y is equal to q of x, first you need to find the complementary function. After that you can go to the particular integral, because of y is equal to, the general solution for y is equal to complementary function plus particular integral. So that's why first you need to write the auxiliary equation of f of d into y is equal to 0. That is f of m is equal to 0. So write auxiliary equation is f of m is equal to 0. That is m square minus 4m plus 3 equal to 0. So now you can find the factors to this equation. We get m square minus 3m minus m plus 3 equal to 0. So means that you can write minus 4m as minus 3m minus m. So minus 1 into minus 3 plus 3 we get the coefficient of means constant value, and multiply the coefficients we get the constant value, and if you add the coefficients of m we get the minus 4. So that's why we can write the factorization by using this minus 3m minus m. So from first to two terms we can common m into m minus 3. Next to two terms you can common minus 1, we get m minus 3 equal to 0. From these two terms m minus 3 is common, right outside, remaining is m minus 1. So m minus 3 into m minus 1 is equal to 0. Here the roots are 1 comma 3. Roots are real and different. So that's why what is the complementary function for real and different? That is complementary function is equal to c1 e power m1x plus c2 e power m2x. So m1 is 1, m2 is 3. So that's why c1 e power x plus c2 e power 3x is a complementary function. Next, going to the particular integral. First write the standard formula for the particular integral. Particular integral is equal to 1 by f of d into q of x. So that is 1 by d square minus 4d plus 3 into cos 2x. So first you have to substitute d square is equal to minus b square, that is equal to minus 4. So here b value is 2. B value is means x coefficient is considered as b. So that's why here b value is 2. So what we have to substitute, d square is equal to minus b square. So that's why we can write minus 4. So we are substituting d square is equal to minus 4. Minus 4d plus 3 we get 1 by minus 4 plus 3 we get minus 1 minus 4d cos 2x. So again we have to apply the same method. You can substitute d square is equal to minus b square. But here only d is there. How can you substitute d square is equal to minus b square? We can rationalize the given function, that is 1 minus 4 minus 1 minus 4d. You can common minus, we get 1 plus 4d, rationalize with 1 minus 4d. That is we can write 1 by minus common, I write here 4d plus 1 into cos 2x, rationalize with 4d minus 1. So 1 by 4d plus 1 minus right here, rationalize with 4d minus 1 by 4d minus 1 into cos 2x. So minus of 4d minus 1. So here a plus b into a minus b, a square minus b square, that is 4d whole square 16d square minus 1 whole square, that is minus 1 cos 2x. Again we get the d square form in the denominators. That's why we can substitute d square is equal to minus b square. So d square is equal to minus 4. If you substitute it, we can get minus, here 4d minus 1 multiply with cos 2x. So that's why minus 1 by, first you have to write the constant, 16 into 4, that is 64, minus 64 minus 1 minus 65, and 4 into d cos 2x minus cos 2x, and all of you know d is equal to d by dx. So that's why derivative of cos 2x, here already minus into minus, it becomes to plus 1 by 65. 4 into derivative of cos 2x is minus sin 2x into derivative of 2x is 2. So that's why into 2 minus cos 2x. We get the value, negative sign common, then minus of 1 by 65. Here 4 into 2, 8 sin 2x plus cos 2x. So this is our required particular integral of the given function. Finally, you can write the general solution is y is equal to complementary function plus particular integral integral. So you can substitute the value. It is a very important one. Y is equal to c1 e power x plus c2 e power 3x minus particular integral is 1 by 65 8 sin 2x plus cos 2x. This is the general solution by using complementary function and particular integral of the given equation. Next example is d square plus 9 into y is equal to cos 3x. First you have to write the auxiliary equation, that is f of m is equal to 0. Then m square plus 9 equal to 0. M square is equal to minus 9, that is equal to minus 1, write as I square, 9 I square. So m is equal to plus or minus 3i. Here it is in the form of alpha plus or minus I beta, but alpha value is 0. So alpha equal to 0, beta equal to 3. So complementary function is equal to c1 cos 3x plus c2 sin 3x. Because of alpha value 0 means e power alpha into x, e power 0 into x value is 1. So that's why I only write c1 cos beta x cos 3x plus c2 sin beta x, beta value is 3. So going to the particular integral, pi equal to 1 by f of d into q of x, 1 by d square plus 9 into cos 3x. But if you substitute, d square is equal to minus b square is 0. Why? B is equal to 3. B square is equal to 9. Minus b square means minus 9. If you substitute here minus 9 plus 9 value is 0. So f of d value is 0. If you substitute, d square is equal to minus b square. So that's why we can go to the second case. Particular integral is equal to x by 2b into sin bx for q of x is equal to cos bx. So that's why we can write the formula directly. X by 2 into b value is 3 sin 3x. So x by 6 sin 3x is our required particular integral to the given function. So finally write complementary function is equal to, y is equal to complementary function plus particular integral, that is y is equal to c1 cos 3x plus c2 sin 3x plus x by 6 sin 3x. This is our required general solution. Next case is particular integral of f of d into y is equal to q of x when q of x is equal to x power k, where k is a positive integer. So for this we can write f of d into y is equal to q of x is x power k. Particular integral standard form is 1 by f of d into q of x. Particular integral is equal to 1 by f of d into x power k. So to evaluate the particular integral, reduce 1 by f of 2 to the form 1 by 1 plus or minus phi of d, means that all the d terms write as a single function, that is called phi of d, that is added or subtracted with constant, that is 1. So 1 plus or minus phi of d by taking out the lowest degree term from f of d. Lowest degree term means d power 0, that is called constant. Whatever the constant is there, you can common from the function right outside, then we can get 1 plus or minus phi of d form. Now write 1 by f of d as 1 plus or minus phi of d whole power minus 1 and expand it in ascending powers of d using binomial theorem up to the term containing d power k. So why we containing up to d power k? Because of x power is k. So derivative is also take up to the power of k only. Then operate x power k with the terms of the expansion of 1 plus r minus phi of d whole power minus 1. So first you need to check the q of x is in the form of x power k. Then 1 by f of d write as 1 by 1 plus r minus phi of d form. After that we can write 1 plus r minus phi of d whole power minus 1 into x power k. That expansion write in ascending order by using the binomial theorem and write up to d power k only. So how to expand this? We have some rules. We are applying that rules. We can expand that one. That is, that rules are 1 by 1 minus d is equal to, means expansion of 1 minus d whole power minus 1 equal to 1 plus d square plus d cube plus so on. Second one is 1 by 1 plus d equal to 1 plus d whole power minus 1. That is equal to 1 minus d plus d square minus d cube plus so on. Here we have alternative signs for the middle and power, so that's why we get the alternative series. So next, 1 by 1 minus d whole square is equal to 1 minus d whole power minus 2 equal to 1 plus whole power minus 2 is there. So that's why we can write carefully with constants. That is 1 plus 2d plus 3d square plus 4d cube plus so on. So next one is 1 by 1 plus d whole square, means that 1 plus d whole power minus 2 expansion, that is 1 minus 2d plus 3d square minus 4d cube plus so on. Next one is 1 by 1 minus d whole cube, that is equal to 1 minus d whole power minus 3, that is equal to 1 plus 3d plus 6d square plus 10d cube plus so on. So we are using the binomial expansion, so that's why we are getting the constants like this: 1 plus 3d plus 6d square plus 10d cube plus so on. Next, last one is 1 by 1 plus d whole cube, means that 1 plus d whole power minus 3, that expansion is 1 minus 3d plus 6d square minus 10d cube plus so on. So by using these important expansions, we can write the particular integral for the form of x power k. So first example is solve d cube plus 2d square plus d into y is equal to x cube. So auxiliary equation is f of m is equal to 0. Then m cube plus 2m square plus m is equal to 0. Here clearly common term is m, right outside we get m square plus 2m plus 1 equal to 0. So m into, this one is the expansion for m plus 1 whole square. So that's why m plus 1 whole square equal to 0, m into. So m is equal to 0, m is equal to minus 1 minus 1. So here we are getting the roots or combination. One root is different, one root is repeated. So that's why we can write complementary function equal to c1 e power m1x. E power 0 into x is 1, so that's why c1 plus next root is repeated twice, so that's why that is c2 plus c3x into e power m2x. m2 value is minus 1, so that's why minus x. So our complementary function is c1 plus c2 plus c3x e power minus x. Next, going to the particular integral is equal to standard formula 1 by f of d into q of x, that is equal to 1 by d cube plus 2d plus d equal to x cube by d into d plus 1 whole square. So here d is a common term, then write 1 by d plus 1 whole square into 1 by d x cube. So we know that d is a differential operator. d is equal to d by dx. 1 by d is a reverse operator, that is integration. 1 by d means integration of x cube. So that's why integration of x cube is x power 4 by 4 into 1 by 1 plus d whole square. So then you can write 1 plus d whole power minus 2 into x power 4 by 4. So here 1 by 4 is constant, right outside, and expand the series, that is 1 plus d whole power minus 2 expansion. Directly we can write from the rules, that is 1 minus 2d plus 3d square minus 4d cube plus 5d power 4 minus so on into x power 4. Why I stop here? Because of x power is 4, so that's why you can stop at d power 4. So that is 1 by 4 into 1 into x power 4 plus 2 d x power 4 plus 3 d square x power 4 minus 4 d cube x power 4 plus 5 d power 4 x power 4. So d x power 4 means one time derivative, d square second time, d cube third time, d power 4 means fourth time derivative of x power 4. So that is, you can write 1 by 4 into x power 4 minus 2 into, so derivative of x power 4 is 4x cube plus 3 into, so second derivative, so already first derivative exists in the first term, you can differentiate this term, so 12x square. So next minus 4d cube, already derivative second order is there, so that's why differentiate this term, that is 24x plus d power 4, d cube derivative is there, means d cube of x power 4 is there, so that's why differentiate that term with respect to x, we can get the 24. So that's why 5 into 24, we get 1 by 4 into x power 4 minus 8x cube plus 36x square minus 96x plus 120. If you multiply the terms, we get this equation. So that is, we can multiply with 1 by 4, particular integral is equal to x power 4 by 4 minus 2x cube plus 9x square minus 24x plus 30. So this is our required particular integral. So the general solution is y is equal to complementary function plus particular integral, that is also write as yc plus yp. So y is equal to complementary function is c1 plus e power minus x into c2 plus c3x plus particular integral is x power 4 by 4 minus 2x cube plus 9x square minus 24x plus 30. This is our required general solution for q of x is equal to x power k form. Next example is solve d square minus 4d plus 4 into y is equal to e power 2x plus x square plus sine 3x. So this sum is with three types of q of x. So q of x is equal to e power ax, and q of x is equal to x power k, and q of x is equal to sine bx, means combination of three forms of particular integral. For any form, first you have to find auxiliary equation, that is auxiliary equation is f of m is equal to 0. So m square minus 4m plus 4 is equal to 0. So m minus 2 whole square, because of this is the expansion for a minus b whole square form, that is m square minus 2 into m into 2 plus 2 square. So it is in the form of a square minus 2ab plus b square. So that's why we can write m minus 2 whole square is equal to 0. So m is equal to 2 comma 2. Roots are repeated. So that's why complementary function is equal to c1 plus c2x into e power 2x. Going to the particular integral, pi is equal to 1 by f of d into q of x. So 1 by f of d, d square minus 4d plus 4 into e power 2x plus x square plus sin x. So you can split as three terms because of three different terms are there. So that is, first term is 1 by d square minus 4d plus 4 into e power 2x plus 1 by d square minus 4d plus 4 into x square plus 1 by d square minus 4d plus 4 into sine 3x. So that is, you can consider as this is a particular integral 1, this is a particular integral 2, this is a particular integral 3. So separately you can find it. Finally you can add the pi1, pi2, pi3. That is a easy procedure to find the particular integral with combination of 2 or 3 methods. So that's why pi1 equal to 1 by d square minus 4d plus 4 e power 2x. So it is a form of q of x is equal to e power ax. So we know that the first case is you can substitute d is equal to a, means a value is here 2. So that's why if you substitute a is equal to 2 in f of d, we get the value is 0 because of it is a d minus 2 whole square form. If you substitute them, d is equal to 2, simply we can get the 0 here. Otherwise you can find by using a is equal to 2. So substitute a equal to 2, 2 square minus 4 into 2 plus 4, the value is 0. F of a value is 0. So directly you can apply the simplest form I gave, that that is you can multiply with x power k. The root is repeated how many times? 2 times, means k value is 2. So that's why you can multiply the numerator with x power k, k value 2, that is x square e power 2x by, so denominator differentiation k times, that is 2 times. So differentiation of d minus 2 whole square is first differentiation 2 into d minus 2 into 1, because of it is in the form of x square. So x square derivative is 2x, so that's why 2 into d minus 2, and d minus 2 derivative is 1, so that's why 2 into d minus 2 first order derivative. Second order derivative is 2 into d minus 2 derivative is 1. So 2 into 1 value is 2. So that's why particular integral is equal to x square e power 2x by 2. So simply you can get the particular integral if f of a equal to 0. So next one is pi2, that is x power k form 1 by d minus 2 whole square into x square. So you need to write in the form of 1 plus r minus phi of d, but here constant is 2, that is d minus 2 is there. So you need to write 1 minus, so that's why minus 2 common, it is whole square is there, we get minus 2 whole square. So minus 2 common means it becomes to plus 1 plus 1. So it is minus d by 2 whole square into x square. So 1 by 4 minus 2 whole square means 4, 1 by 4 write outside constant and write this term as 1 minus d by 2 whole power minus 2 into x square. We are using the expansion 1 minus d whole power minus 2. So in the place of d we have d by 2. So that's why we can write the expansion is 1 plus 2d plus 3d square plus so on. We can stop at d square term because of we have x square. So that is 1 by 4 into 1 plus 2d. So 2 into d value is d by 2 plus 3d square, 3 into d by 2 whole square plus so on into x square. So now you can simplify first, that is 1 by 4 into 1 plus 2 to cancel plus 3 into d square by 4 into x square. So multiply with x square, we get 1 by 4 into x square plus 2x, derivative of x square is 2x plus 3 by 4 is constant, d square of x square, first order derivative is 2x, second order derivative is 2. So into 2 you can write, cancel in 4, that is 2 times, then we can get pi2 equal to 1 by 4 into x square plus 2x plus 3 by 2. So last particular integral pi3 equal to 1 by d square minus 4d plus 4 into sine 3x. So this it is in the form of sine bx. You can put d square is equal to minus b square. B value is 3, so that's why d square is equal to minus 9. Then you can substitute d square is equal to minus 9. We get 1 by minus 9 minus 4d plus 4 into sine 3x. We get the value is 1 by minus 5 minus 4 plus 4, sorry, minus 9 plus 4, we get minus 5 minus 4d into sine 3x. You can common the minus. We can write minus 1 by 4d plus 5. Again you have to write in the d square form by using the rationalization, that is 4d minus 5 by 4d minus 5 into sine 3x. So then you can multiply minus of 4d minus 5 by a plus b into a minus b, a square minus b square. Here 4d whole square 16d square, 5 whole square 25 sine 3x. Again you have to substitute d square is equal to minus b square, that is d square is equal to minus 9. Then you can write minus of 4d minus 5 sine 3x by 16 into d square is equal to minus 9 minus 25. So we can get the constant term is minus 1 by minus 169, and sine 3x multiply with 4d minus 5, that is we can write is 4 into d of sine 3x minus 5 sine 3x. So then we can write minus into minus plus 1 by 169. Derivative of sine 3x is cos 3x into derivative of 3x is 3. So 4 into cos 3x into 3 minus 5 sine 3x. So 4 into 3, 12. So we get 1 by 69, 12 cos 3x minus 5 sine 3x for particular integral 3. So finally you can write particular integral is equal to pi1 plus pi2 plus pi3, that is pi1 is x square e power 2x by 2 plus pi2 is 1 by 4 into x square plus 2x plus 3 plus pi3 is 1 by 169 into 12 cos 3x minus 5 sine 3x. Finally you can write the general solution is, so y is equal to complementary function plus particular integral, that is y is equal to complementary function is c1 plus c2x e power 2x plus x square e power 2x by 2 plus 1 by 4 x square plus 2x plus 3 by 2 plus 1 by 169 into 12 cos 3x minus 5 sine 3x. That's all for today.